Okay, class, go ahead and turn to your Day 6 notes on scientific notation. What scientific notation is, it's a short way to write very large or very small numbers. We're talking numbers with lots of zeros in them, whether they're really big with lots of them at the end or really small words, 0.000, etc. Okay, so this is just a different way of writing numbers. When a number is written in scientific notation, it's written in this format. It says A times 10 to the nth power. So what we need to know is, well, what are these things? Well, the A is a number between 1 and 10, and that's really important. So when we're writing in scientific notation, we want it to be a standard form. We want this number to be something between 1 and 10. Okay, so I'm going to put a box around that. Okay, and I'm going to put a box around this as well. Okay, and then the n is an integer. Okay, what the n is going to tell me, that's going to tell me how many times to take this number and move my decimal place over, because that's how many tens I'm multiplying it by. Because when you multiply by 10, it always just moves your decimal one spot over. Okay, so let's see how that works. Okay, so if I have the number 1.35 times 10 to the 5th power, and I want to write it in standard form, what I want to do, I start off by just rewriting the 1.35, okay, and then I'm multiplying by 10 5 times. So what I'm going to do, each time I multiply by 10, it moves my decimal over. So I'm going to take my decimal, which is right here, I'm going to move it over 5 times. So 1 puts it after the end of the 3, 2 puts at the end of 5, and then I got to keep going. So there's 1, 2, 3, 4, 5. So I'm moving my decimal from here over this way. So what do I fill in the blanks with? Well, I fill those in with zeros. Okay? So then I end up with this. Now I don't want to leave my answer looking like that. I want to write it as an actual number. So it'd be 1, 3, 5 with 3 zeros. Okay, and then make sure you remember to go back and put in your comma every 3 numbers. So 3 numbers over would be 135,000. Okay, so again, this is just your regular standard form of an equation. This is your scientific notation form. So it's just showing you 2 different ways of writing the same number. Okay. All right, now this one, 2.7 times 10 to the negative 3rd power. When we have a negative exponent, it ends up moving the decimal backwards, making the number smaller. So again, I'm going to start off with my 2.7, okay, and moving my decimal 3 places, but to the left, since it's negative. Negative, again, will make it smaller. So 1 place moves it in front of the 2, and then 2, 3. So I'm moving my decimal from here over to this spot right here. So then again, I fill in my blanks with zeros, and then I want to rewrite this so it looks like normal numbers. So 0.0027. And let's put a 0 for our, in front of our decimal like we normally have as well. All right, by the way, one thing I forgot to mention, you can always check these answers out. If the number is not too big, you can check it out by typing this in your calculator, and it should give you this answer. Okay. All right, so positive exponents make the number bigger, we move it to the right. Negative exponents make it smaller, we move it to the left. Okay, so now we have another example. 2.87 times 10 to the 9th. So 2.87, okay, my exponent is 9, so I need to move my decimal 9 places, and it's positive, so I want to make it bigger, so I got to move it to the right. So there's 1, 2, and then 3, 4, 5, 6, 7, 8, 9. Woo, lots of times for this one. Okay, so I'm filling it in. I've got 2 numbers I moved it over, so I've got 1, 2, 3, 4, 5, 6, 7 zeros to plug in there. Okay, so when I rewrite that, I've got 2, 8, 7, and 1, 2, 3, 4, 5, 6, 7 zeros. Okay, so let's count over 3, put a comma, count over 3, put a comma, and then 3 more and put a comma. 100,000 million, so 2,870,000, then is how big that number is. So this is a good example for a pretty large number that it is nice to write it in scientific notation. It really shortens them up, especially when they're really even bigger than this. All right, so we got one more here, 1.9 times 10 to the negative 5th. This time my exponent is negative again, so I want to make my number smaller. So there's my 1.9. I'm going to move it 5 places to the left to make it smaller. Okay, 1, 2, 3, 4, 5. Okay, so one place, put it in front of the 1, and then I have 1, 2, 3, 4 zeros. Okay, so altogether that's 5 spots I moved it. So then I just rewrite it. 1, 2, 3, 4 zeros, 1, 9, and then put a 0 in front of my decimal. All right, so that's changing from scientific notation to standard form. So now we're going to switch it up. Now I'm going to give you just plain old standard form, what you're used to, and we're going to write it in scientific notation. All right, so what we want to do, remember this first number, this A, is supposed to be between 1 and 10. So currently my decimal is at the end of the number. I'm going to move it over until it makes a number between 1 and 10. So I start moving it over. So boom, boom, boom. Well, if I put it there, that's 543, so that's not going to work. Move it there would be 54.3. So I want to move it right here, which would make it 5.43. So I'm going to write that, 5.43. Okay, so that meets my requirements of being between the 1 and 10 there. Okay, and then now in scientific notation, we always write the times 10. Okay, and then the exponent is how many times I moved my decimal over. Well, let's see. To go from where it was to where I moved it to, we moved it over 1, 2, 3, 4, 5 numbers. So there's 5 numbers between where my decimal was to where I moved it. So it'd be to 10 to the 5th power. Oops. Right. All right. Again, you could check this out by, if you type this in your calculator, it should give you that number in standard form. Okay, so this number now is a small number. So big numbers, we're going to have a positive exponent. When we have those small numbers, and what I mean by small numbers, I mean numbers that are less than 1, you want to make, you're going to end up with a negative exponent when you write it. Okay, so right now, obviously, this number is not between 1 and 10. So where do I want to move it to? Well, if I put it here, I've got 0.7, doesn't work. Here makes it 7.09, so that's going to work. So I got to move it 3 spots over to get there. So I'm going to write 7.09. Notice any of my extra zeros I leave off because those are just placeholders for where my decimal was before. So I got 7.09 times 10, and then we moved it 1, 2, 3 spots to get there. So instead of just writing regular 3, I would write -3 since this is a small number that's less than a whole. All right, and then that's it. Okay, so we got one more example. Again, it's a small number. So we want to move our decimal. Okay, again, I can't put it here. That would make 811. This would be 81 here. Right here, though, would make it 8.11. So that's where we want to move it to. All right, so 8.11 is a number between 1 and 10. So that meets, again, the requirements of what A should be. And then always times 10. And then let's see, we moved it this time 1, 2, 3, 4 spots. So 4 numbers between where the decimal was versus where we moved it. But since it's small, we write -4. All right, so that's it. Those are your notes on scientific notation.